So subdividing a segment in a given ratio is a new topic for the 2015-2016 school year, and that means there's not as many resources for this topic as there are for some of the other ones. So it's a good thing that the student edition and the teacher edition have some good resources that you can use in your classroom. Let's start out with the exploration. I really like this because it starts out concrete. It starts with where you might really use this in real life. I just reset it so that the answers that I did earlier would be cleared. So to partition a segment in a one-dimensional coordinate system, we're going to talk about traveling down the highway. And we're looking at three different streets here. The Arthur Avenue exit, the Collingwood Road exit, and the Briar Street exit. So A, B, and C. We're going to start at exit 3, and we're going to go on to mile marker 43. The first thing that you have to do is mark both of those on your number line, which is kind of tricky because the circle is too big. But do your best. If you don't get it, it'll let you try it again. Ha! First try. So the distance from 3 to 43 is 40. I've already answered this in apparently. And then the next question that the program will ask the students is to find how far that will be from the Arthur Avenue. So since Briar Street is 3/4 of the distance, you're going to do 3/4 times 40. That's 30 miles. So to find out where the mile marker for Briar Street would be, students will have to add 3, that was their starting point, to 30, that's the distance they traveled. And the mile marker is going to be at 33. Here's the next challenge. Have to try to mark 33 on the number line. And remember, this is really representing a highway here. There we go. There's another example for you to work with your students too. Now remember, you have the option to do this on notebook paper. To do it on notebook paper, just have your students draw the number line on their notebook paper. That becomes their highway, and then they can follow along with you as you guys answer these questions as a class. You might then ask them to try the one for Dakota Lane independently. So this is a very concrete example. To look at an abstract example, let's go to explain concept 2. Here we're going to look at it just geometrically. Here we have a directed line segment, and we want to divide it into a ratio of 2 to 3. Here's a visual for the students. They can see the left half is a little smaller than the right half. And I shouldn't be saying halves because those aren't halves. It's not 1 to 1, it's 2 to 3. And then the line segment is going to be partitioned 2 to 1. So here, the left section is much larger than the right section. So students can see the difference in a 2 to 3 ratio versus a 10 to 1 ratio. That sort of helps them understand the goal that we're looking at here. Then the directions for doing this on the coordinate plane follow, as well as an example for you to work together with the class. So the way the standard reads, we want the students to find to subdivide the segment using coordinate proof. However, it can also be done using constructions. This is just another method of getting it. So concept 3 shows the kids how to use constructions to subdivide a segment by creating congruent segments. Just remember that what the standard's looking for is the coordinate method. And since we probably need some more practice problems with this, go on forward to the evaluate. And there's a set of 25 problems for you to work here with your students. This is a great resource since not very many of these have been produced.